Hey everybody! With this video I'm starting a new series called #Blendit. In this format we will try to replicate artworks from other creators who use a bunch of different software for the projects, like Maya, 3ds Max, Houdini, Cinema 4D or After Effects. The goal is, however, to do everything 100% in Blender from start to finish and see how close we can get to the results. And, of course, always learn something along the way. In this video we will be creating this awesome artwork from Mikey Dowdle. Be sure to check out his website and all of his amazing work through the links in the video description. If you have any suggestions for future artworks, which we should try to recreate in Blender, be sure to send them to me through one of my social media channels. Links for those are also in the video description below. Now, before we are diving into Blender and getting too technical and hung up with the nodes, objects and the lights, let's quickly talk about the blueprint for this project, so to say, a step-by-step guide of what we actually have to do. First, we start off by creating a grid and transforming it to a rectangle along the x-axis. We will further transform it so that it is slimmer on one side and wider on the other. This shape now gets duplicated, scaled and rotated a bunch of times so that we end up with this shape from the original video. We will use a wave texture to displace the mesh along the y-axis. With the help of a few logic and vector nodes, we will mirror this effect on the negative value range as well. After that, we create an area light, which we scale up so that it is big enough to cover the whole object. We use 3 different mask riff textures, color them individually, and use a little math trick to mirror them as well. After that, we animate the textures to move along the x-axis over time. Now, the rest of the magic happens in the Compositor, where we play with different settings like contrast, gamma or exposure, as well as adding glow and grain directly in Blender's Compositor. With that said, now let's get into Blender and blend it. So, now here in Blender, we start off by getting into the Geometry Nodes tab and creating a new Geometry Node system. We are going to delete the input geometry and we are going to use a grid. And using it as the input here. Then we are going to use a transform geometry node. And we increase the size of our grid along the x-axis. Let's make it like 10 meters. And then we're going to translate it on the x-axis by 5 meters. So we are starting at the world center here. Now we're going to use a set position node after that. And now we are going to use a little bit of calculations. Let's use a position node right here. And also use a separate XYZ. So we are going to use position, which is a vector, and we're going to separate it along the X, Y, and Z axis. And if we press Ctrl Shift and left click, we can always preview the values. But for this to work, we also need a geometry. So we can come up here and also Ctrl Shift and left click so we see what the values actually do. And we can see here, if we look at the X axis value, we can see from starting from the world origin, it gets always brighter until it gets white. And at the origin, it is 0. That's why it's black. And basically what we're getting here is a gradient from 0 to 1. But after it reaches 1 here, we don't have any values to go higher than 1. So it's always getting white. So what we can do here is we're going to use a map range node. And we know that our mesh is like 10 meters long. So we can put in from a minimum and from maximum value, and we increase the maximum from the values we're giving it to 10, and we are mapping it to a range of 0 and 1. So that's why now the gradient works and is correct in our case. Now we're going to use a combine XYZ node, and we're going to use this at the Y input. And now we put this, let's also get a vector math node. Here, we'll put it to multiply and leave the X and Z vectors on 0. And now we're going to multiply this with the position from before. And now when we plug this into the offset, we can see that our mesh is thinner on the side where it's on the world origin, and it gets bigger on the side where it's going further away. That's exactly what we wanted to do. Now we can also increase the size or decrease the size of the minimum, and it always works like we want it to. Let's just clear this up a little bit and move it a little bit more back because we don't need it anymore. So next up, we have to duplicate and scale and rotate our original mesh to make our duplicates. For this, we're going to use a transform geometry node like this one here. And I have the values right here. We have to transform this by 0.5 and on the z-axis by 10 degrees. And we're going to scale it down by 0.5 on the y-axis. Now we're also going to duplicate this and put it directly after this. And we're just going to scale or set this value up to 0.5. And now we use a join geometry node. And we're going to input both of these values. And now you see we have two duplicates on the positive value side on the y-axis up here. Now we're going to duplicate one more transform geometry node here, and we're going to reset these values. And we're going to set the y-axis here on -1. So we're flipping it and we're duplicating it on the negative side. And now we are also going to, again, take a join geometry node, joining the first duplicates up here and also the original geometry so that we end up with this shape from the video. These are a few nodes. So also again, take these, push them together and make with Control J a frame. Oops, select everything, select Control J so to make a frame. And with F2, you can label it and say this is our transform area. And we can put it off a little bit to the side. And now is probably coming the hardest part of this whole tutorial. We are going to get a wave texture for the displacement. And we also get a set position node. And we put it right up here. And when we get now a combine XYZ, we can see that if we take the color value here and put it in the y-axis and put this here into the offset, that now if we go to the face offset and say #frame divided by like 10, we can see that something is happening. But it's not really pretty and it's only working in one direction. So what we are going to do is we are going to take a map range node and duplicate it. And what we are getting here is a value between 0 and 1. For the first one here, it is completely fine. And what we don't want to do here is we want to flip it so that it's from 0 to -1. So it's negative. Now we also get a switch node. If you've never worked with the switch node before, you can basically think of it. We input here a condition and say, check this condition up here. And if the condition here is true, use this input up here. And if it is false, use this input down here. And the input is what we get out of here. So to use this now correctly, we will use a compare node up here. And we are going to use a greater than function. So it's already working. And we also need, from the beginning, we also use a position attribute like we had in the beginning. And also we can copy it from here, a separate XYZ node, input this here. And now let me quickly show you this. I will unplug this whole thing here so we can see a little bit better. When we now press Control Shift again and look at the values we get, we can see X like it was before. And now when we look at the Y value, we see that everywhere where we are at the positive area, because like this is the X, Y, and Z values. So where you can see the big dots up here, these are all the positive values, and in the other direction is all the negative values. And now we can see here, everything where it is white, this is up above 0, and everything where it is black, it's below 0 or 0. So what we want to do now, we want to use this as the greater than function. So when we look at this now it is above 0 and below 0. And this is our condition which we're gonna check. Now you see we have a red line. This means because it wants to check something of some sort of geometry, we are going to change this to a float value. When we now input it here, now it's working. And so we leave this down here, and we are getting now I think it's flipped around. So let me quickly change this. Okay, exactly. If this condition is false, so if it is not above 0, we want the values to apply in the negative direction. So this is our false statement. And here is our positive statement. So if we use this here, this is now our true statement. And now we take this output, which is either one of them, depending on what exactly is happening right now, and taking this as our combined XYZ node. Now we can use this output of the vector as the offset. And now when we look at this, we can see that it's still really bad. And this is because I think I forgot, to increase the vertices in the beginning here. And you can see now a lot is going on. Let's maybe increase it like to something of 50 and decrease the scale value here by a lot, like 0.20. 0.05, something like this. Yeah, okay. Now when we look at it, we can see that definitely something is happening, and it's looking correct, like we intended to. We can of course go in here and say minus, so it's moving in a positive direction. Exactly, perfect. Now what we also want to achieve is another effect, that at the beginning the displacement of the wave texture is not working at all, and the more it comes out of the world center, the more the effect of the wave texture comes into play. So how we can do this is now also like in the beginning, we can take this from the separate XYZ, we can take the X output and we can copy again the map range node and put it in here and say again, like 0 to 10 is already working fine. When we look at it, it works perfectly. Now we also can copy the combined XYZ node up here, also use this as the input of our Y axis and use a vector math node again, set it to multiply, and we're going to multiply these two values up here. And now when we plug this into the offset, we can see that the effect is starting off really subtle, really small, and it's getting more effective as it moves out. Perfect. Now there's also one more effect I want to show you, and this is that the effect should be more extreme in the center of our mesh and more dampened on the left and right side of our mesh, so that the small lines up here and down here should not be moving as much as the center of our mesh. So to achieve this, we have to also again use this XYZ node here, and I'm going to move down here to make some space for the new nodes. We first of all need a math node and use the Y axis up here. Just to look at it again, if we look at the Y axis up here, we can see if we go now down here and multiply this by -1, that we get exactly the flip side. And this is what we want, kind of, but we want to have the higher values here in the middle and smaller values down here to the side. And a way to achieve this is to use a map range node, or better said, we use two map range nodes. But for this second map range node, we use the Y value up here again. And instead of 0 to 1, we change this from 1 to like 0.5. You will see what's happening in a minute. And from it's here, we're doing the same thing, but we have to invert this first. And now you can already kind of tell that the higher value here is in the middle, and it gets smaller and smaller along the axis down here, and we can still control the effect and the amount of it. So now we let it at 0.5. We again need, of course, combine XYZ and combine XYZ nodes here on the Y axis. And we are going to use again this switch value up here, but we can leave the condition the same. So we just want to check if above or below 0. And now these are our new inputs. No, come here, perfect. And we are going to use this is our second switch, perfect. We're going to use a multiply node and multiply these two up here and put this one into the Y value. And now you can see that if I turn off this preview, in the middle, the effect is more extreme because we inverted the Y gradient we get from the position separator. We flip this along the x-axis, so we have a gradient in both directions, and then we invert them. So we have the higher values in the middle and the smaller values to the left and to the right. Basically, this is what's happening here. And the good thing is now this is working. Just be sure to, because I flipped it before, that the false and true values are correct here. And the good thing is here now we can still change these values later on. So we can increase them to 1 if we want to have the full effect. Let's go here to 1. Now we have the full effect again, but we also can go here like to 0.4 or 0.4 to have a more dampened effect on the sides. And I know this was quite something down here. I hope you could get along with this. But now our mesh is really finished and we are ready to go to the lighting. In this case, we don't need a special material because everything what we're going to do now is just lighting as is. So we don't have to care about our materials. And now I'm here in the shader editor and we're going to create an area light and move it down here and scale it up a lot so that it really covers our whole mesh here, and scale it along the y-axis. And what we have to do now is like also go into in the rendered mode, and we're going to use the cycles render engine. Don't worry about cycles. It's like really fast what we are going to compute, and even older computers and weaker graphics cards can definitely do what we are going to do now. But why we need cycles is because here in the light properties tab, we're going to select this feature called use nodes. And now we can use like shader nodes typically and control our light source here. And a way what we want to do now is we can add a Musgrave texture and use an color ramp up here and connect these two. And when we use this as the color input, and when we switch over to the rendered viewport and decrease the strength, we can definitely see when we lower this value and increase the strength that a texture pattern can be seen up here. So we can also increase the contrast with the color ramp here. You can see something is happening. And we're going to use this effect and we're going to add something a little bit more complicated, to be honest, but it will be really worth it. And what I just did is press Ctrl T on the Musgrave texture, and everybody who has the Node Wrangler add-on enabled, and I think this is basically everybody who uses Blender nowadays, we get this texture coordinate in the mapping node here, and we are going to use these two and transform them. Again, with a separate XYZ node, we have used them a lot today, and another combine XYZ node at the end here, and there is now something happening in the middle here. And what we're going to do now is we are going to take the Z value, put it into the Z socket, and disconnect the X right now. And what we want to do here is we add a math node, and up down here we are going to use not add, but we are going to use absolute and use Y up here and put it into the Y-axis down here. And we're going to use another math node up here, put it back to add, and use the X value for this one. And I don't want to get into all the math, why it works, but this absolute function down here basically mirrors our Musgrave texture along the Y-axis. And so we have the same light effect going on the left and right without doing any more or mirroring anything else. And we have this add math function here for the X value so that we can animate our function along the x-axis. So this will be our function, what typically would be our W function in here. And now with this setup, we are basically just going to duplicate this with Shift D, copy it down, arrange it a little bit nicer, Shift D, copy it down, and move this a little bit more down here. And now we are going to use a combine. Nope, I think it was a mix. Oops. It was a mix color node. Yeah, exactly. And instead of mixing, we're going to use the option of adding the colors on top of each other. So now if we use this one and copy this one again with the result of this one, then we can see basically everything is white. And this is because we have to give some colors first. And now you can really be creative and maybe use some different colors like I used in the intro. This one is maybe going to be green, the first one is red, and this one is going to be blue. Now, this is all going into the color, and we can see we can also change the strength and the values up here. And now we still have the problem that it's still the same color. And that is because every Musgrave texture now has the same position on the X value. So what we're going to do is we're going to use another value function in here and type hashtag frame divided by like 15 and put this one here into the add function. And now we can see a little bit bad, but the X function is really moving the red color. It's moving into the wrong direction, I can see. So this is why I'm going to use here a negative value. Now it's moving in the right direction. And now we can copy this down here, but we all have to change this settings again. In here we have frame, let's say -25. And here we have frame divided by, let's say, -35. So we have a decent amount of different values here and all combine them in here. And now you can see that I could try to denoise it. Ooh, no, this looks bad. We can see that we have this nice rainbow effect of different colors all moving down. Now, if this is too much of colors like intersecting and joining with each other, we still can change the scale of each value individually. But what we also can do is a really nice effect here in the light properties. We can reduce in the beam shape settings the spread of our values. And if we go down to 1, we can really see how our Musgrave textures are looking when they are moving around. This already gives a really cool effect. And with the spread value here, you basically it's like a roughness factor or like a mixing factor of how much spread, and it's blurring the values a lot more apart. And something like, I think something like 65 here is really looking nice. And we have still these punchy contrasty colors, which are nicely separated by each other. Or you can even go higher to like 120, and then it's really nice and mixing itself up together. Depends on whatever you want to accomplish with this and what you want to create, but it's nice to have these options here, and it's really fun to play around and find the perfect settings for this. Now, what we still need is a sphere. We're going to create a UV sphere, for example, subdivide it once and shade smooth. And now we're going to scale it and move it along the x-axis so that it's right up here. And we are going to use this view on number 3, Control-Alt-0 to set the camera. And now we are going to change some settings in the format up here. We want to have a vertical resolution like what we had before, 1080 by 1920, so full HD in vertical mode. And what I used for my final renders are 12 FPS. You have to choose custom settings to get this. And then we can, if we have the camera selected, we can move a little bit more upwards. And I think I chose something like 24 millimeters. Change a little bit of the rotation to like 60 and get close to our mesh and find the perfect setting for you, whatever you like. And now we have this nice effect here with the ball. We can still move it a little bit more closer. And now we have this awesome effect here. And before we're going to render it, like I told before, we can leave the noise activated. And instead of 4000, we're going down to only 16. And we're going to increase the noise threshold to something like 0.1. So it's going to render really, really fast. And the denoising function here is really working wonders for us. If you can, and if you want, you can also like increase the maximum samples. Always looks a little bit better, I think, but for what we are going to do right now, it's perfectly working out. I think I have to still increase it a little bit more, like the strength to 100. And now we can start and make a render. Press F12. Perfect. Now with the render finished, we're going into the compositing tab. And here is our last step, what we are going to do. We are going to create a new window up here and using the, what is it called? The image editor, and in here we are going to preview the viewer node. But first we have to enable here, use nodes, and also press Ctrl Shift and left click to preview the image we just rendered. But in here we can deselect backdrop and see here what we are basically doing all the time. Here are a few things we can do for the compositing, which I did to match the original as closely as I could. First of all, we're going to use a color balance node. And in here we can decrease the lift value, which is like decreasing the brightness of our image a little bit more. And we're going to increase the gamma values of our image. So we're getting this nice contrast look on our colors. And I know it looks relatively cheap now, but it will get there, trust me. Now in the next step, we're going to use a hue saturation value node. And we're going to increase the saturation and decrease the value by 0.2 to 0.8. And in the next step, we're going to use a glare node, which is going to give us this glowing effect. And in case to match this original as best as possible, we're going to use simple star for the first one here. And we can see if we decrease the threshold to like 0, that everything is really bright. And we can increase the iterations to like 4 or 5. And now you can see this is the star glow. So we have like these edges here everywhere where the brightness is valid. And I'm going to use it like 4 would be best. Yeah. And if the mix is at 0, it basically mixes the image. Like 1 is the output, what we would get of the glare node typically, and -1 is the original image. And 0 is basically a mix between these two. And what I'm doing here is I'm going to subtract 0.5 so we don't get all of the glare. We have just a little bit. And then we're going to use this glare node again. And instead of simple star, we're going to use fog glow, which gives us a more of a shine along these stars we already have and along the values of the colors. And in here, we're going to decrease the size a little bit to 7, and we're going to mix it all the way. Perfect. And now I also used a brightness and contrast node and increased the brightness just a little bit by 0.5. And for the last step, we're going to add the grain to our image. And we're going to do this by using a texture node down here. And we just have to first create a texture. So we go down to here to the texture tab, create a new one, and say here noise. So we get really random noise basically, and we can now select it here in the texture tab in the node editor. And now we're going to use a color, it's called a mix node like this. And using this input and this input. And now we're going to use multiply. So we're multiplying the noise on our original image. And when we'll have a look at it now, it looks terrible. This is because the factor is at 1 and we want to have a smaller value like something 0.3, 0.35, something like this. You can play around with these values. And now you can see if we look at this image, we have this grain. We also have this glowing effect here. And I think it looks really cool. And yeah, this is basically what I did to recreate this effect. In this case, I think the colors are still a little bit too saturated for what I have done earlier. So you can probably play around here a little bit more and whoa, that's a little bit much. Yeah, and desaturate the colors to your liking. And with the render settings we have right now, this really renders fast and you don't have to worry about the performance of your computer. And that's basically it. These are all the values and nodes which I use to create the renders you can see here. I hope you could follow along and enjoyed this first episode of Blendit. And again, if you find something online that you want to see recreated in Blender, send it to me on one of my social media channels and I will have a look at it. Thanks so much for watching and I will see you in the next one.